Hello everyone, welcome to another video of Cloud Deep Dive. In our previous video, we talked about Route 53 resolver endpoints, what challenges our customers had for hybrid environments, and how these endpoints help them to overcome those challenges. If you haven't watched that video, I would recommend you to go and watch that video first. That's the part 1 of this Route 53 resolver endpoints, and I will provide the link of that video in the description below. So in today's video, I will show you how you can create these endpoints, and we will simulate a hybrid environment and where we'll see how these endpoints works in action. So guys, for this demo, we will simulate a hybrid environment, and for that what we'll have our AWS cloud and we'll have our corporate network. To simulate the corporate network, what we will be doing, we will create a AWS VPC. In that, we'll create subnets and we'll create an app server and the DNS server in that. And I will provide you a CloudFormation script which you can use to set up this environment. Similarly, on the AWS side, we will create a VPC, two subnets. We will create a EC2 instance and a Route 53 hosted zone. Um, and our main goal is we'll try to resolve uh, DNS name of this app server from this EC2 instance. Similarly, we'll try to resolve EC2 instance DNS name from this app server. So when we develop this environment, deploy this environment, they obviously won't be able to talk to each other because they are two separate environment and they are running in their private zones. So to provide the connectivity in normal environment, what companies do, they might create a VPC connection, sorry, site to site VPN connection, or they might have direct connect. But because we are simulating this, so what we will be doing, we'll create a peering connection between these two VPCs. And after creating this peering connection, this EC2 instance will be able to ping the app server, and the app server will be able to ping DNS, sorry, IP address of this EC2 instance, but they won't be able to resolve the uh, DNS name of each other. So let's first do that part, and then we'll move forward and see that how the endpoints will help us to resolve these DNS endpoints. Okay guys, so to create that hybrid environment, you will need CloudFormation templates, and I have already created those templates and will provide you the link of this GitHub repository in the description. So there are two templates, one to create the AWS side of the environment and another one is to create the on-prem side of the environment. If we look at the AWS side of the environment, it will create a private hosted zone, will add a record, we'll create a VPC with subnets, private subnets, and we'll create route table, associated security group. In addition to that, it will create a EC2 instance, its role, and in the end, it will have some SSM interface endpoint so that we can connect to this EC2 instance. So that's all it will be creating towards my for my AWS environment. Next, if we look at the on-prem side of the CloudFormation template, it will again create a VPC and some subnets. Accordingly, it will create the route tables, security groups. In addition to that, we will be deploying two DNS servers for high availability. And here's the user data is provided for those DNS server to do the setup. So it will create all the setup, but after deploying it, we have to make some changes, and I'll let you know that what all changes you need to do it once we deploy this template. So this is DNS server 1 and this is DNS server 2. In addition to that, we will create a app server from where we will be trying to connect to my EC2 instance, and from my EC2 instance we'll try to connect this app server. And in the end, we have some SSM interface endpoints which we will use to connect to these EC2 instances. So these are the two files you will need. Just download it, and then we'll go to our CloudFormation template in the console and we'll deploy both of the templates. So what I will do, I will deploy AWS underscore DNS template AWS side on the in the Ohio region, and I will deploy my on-prem environment in the Europe region, the Frankfurt region. And I'll also create a pairing between those two environments. So I'll pause the video here. We'll deploy both the templates. They're straightforward, nothing to show in that, and we'll create the pairing, and then I'll show you what all I have created. Okay guys, I have deployed both the templates, and on the AWS side in the Ohio region, it created bunch of resources what we mentioned in the template, and you can see we got one EC2 instance in the Ohio region which has a private IP address. Then we got the Route 53 hosted zone, private hosted zone, and it's connected to my VPC which we created as part of this template in US East 2. And we added a record saying web.aws.clouddeepdive.org should go to my EC2 instance, which is the IP address of my EC2 instance, .35.61. You can see .35.61 is the IP address of my EC2 instance. Similarly, on the Frankfurt region, we deployed our on-prem CloudFormation template. It created all the resources. If we go to EC2 instance, we have two DNS servers and one application server running here. Apart from that, what we have done, we have created the peering connection between these two VPC. So this is the peering connection I have created between my AWS environment and my on-prem environment. So by doing that, my on-prem environment EC2 instance will be able to connect or ping to my app server, and app server will be able to connect or ping with my EC2 instance, but they won't be able to resolve any DNS. So if we look at the diagram, right now we have one app server, two DNS servers installed on my on-prem site. We have one EC2 instance. We created a Route 53 private hosted zone with the A record in that, and we have created the pairing connection between these two. And on a notepad, I have noted down all the IP addresses and the DNS name, which we will require later in the video. Okay guys, next let's connect to my app server and see whether we are able to ping my EC2 instance or not on my on-prem. So we'll select that, we'll click on connect, and we'll use session manager to connect to this EC2 instance. It will open a new window and it will connect to that. So I'm just kind of making sure that you can see what I'm typing here. So we'll use our EC2 instance IP address. So let me go and copy that EC2 instance IP address of my AWS environment, and we'll do ping, and you can see that we are getting all the bytes from there. So that means that we are able to connect to the EC2 instance running on my AWS environment. Next, let's see that can we connect to the DNS server. So if we try to ping web.aws.clouddeepdive.org, it will say the name service not shown. So that means that it's not able to resolve the DNS name of my EC2 instance running in my AWS environment. So next, let's see how we can solve this issue. So for that, we will be creating some inbound endpoints in our AWS console, and I'll show you how we can create it and how it will help you to make sure that this app server is able to resolve the DNS name of my EC2 instance sitting in my AWS environment. Okay guys, so we have completed our environment and it looks like right now like this, that we have AWS side and we have corporate side, and we have a peering connection between these two. The EC2 instance and the AWS and the app server EC2 instance can talk to each other, but they cannot resolve the DNS name of each other. So next, what we will be doing, we will create two inbound endpoints on the Route 53 resolver endpoints, and after that we will update our DNS and app server. So in our DNS server, we will update the zone file saying that any DNS related query which belongs to AWS cloud, send it to these endpoints, and app server will link it with our DNS server, mentioning that any DNS related query, use this DNS server to resolve those queries. So once it is done, after that, any query coming from the app server to this DNS related to AWS DNS records, it will be sent to these endpoints, either one of these endpoint. And once it is there, it will check the Route 53 resolver hosted zones. Since we already have a private hosted zone with the data, with the a record of this EC2 instance, it will resolve to that IP address and will send it back to the app server. By using that, it will be able to connect to this EC2 instance. So let's go to our console and see how we can create this inbound endpoints, how we can update this both this DNS server and app server, and after that how our query will be resolved to an IP address. Okay guys, I have logged in into my AWS console and I will go to Route 53, and under that I will go to inbound endpoints under resolver, and we will create an inbound endpoint. One thing to remember that we have to create this endpoint in my Ohio region because that's my AWS environment, and there we will create all these endpoints. So let's click on create inbound endpoint. We will give a name. You can give any name. Then we will choose the VPC in which we will create this endpoint. So we will be creating in our VPC where we have our AWS environment running, and we will choose a security group. So as part of CloudFormation stack, there are two security groups is created. So you will choose the one with the AWS DNS, AWS security group. Then we will choose in which availability zone we will be creating this endpoints. So I'll choose 2A and then corresponding subnet. I will let choose system choose an IP address automatically from the range of the subnet, or if you want you can specify your own IP address as well from this particular range if you want. And for high availability we'll create another one in 2B. We'll choose subnet and we'll let them choose their own IP addresses, and after that we'll click on submit. So it will create an inbound endpoint, and what it will do basically, it will create two ENI into different availability zones, and we'll get the IP address of these two ENIs. So we need to note down the IP address of these ENIs because we will be using these ENIs IP address while updating the zone file of our DNS server on the on-prem. So let's note it down. Okay guys, so I have noted down both the IP address of my inbound endpoint, and next what we will do, we will connect to my DNS server A, DNS A, and we'll update the zone file in that particular DNS server. So to update the uh, zone file, I have already pasted one zone file data under my GitHub repository, and link I will provide in the description. So in the zone file, you will see this record we need to update inside the DNS server. And before doing that, what we will do, we'll replace these endpoints with the inbound endpoint we have created. So let's copy this file, and this is the DNS server which we have created and we have connected to. Another thing what we need to do is, in addition to copying this, we need to use some commands, and I have provided those commands under the commands file in the same GitHub repository. So first we have to connect to the DNS server, which you already done, and then we have to start giving these following commands. So first we will do cd/etc. So we will go to our DNS server, let's say cd /etc, and then we have to open our named config file. So we'll say sudo nano /etc/name/dot config. So it will open the config file, and what you need to do, you have to go to the bottom of the file and you will take this zone file and you will paste it here, and in that you have to do a little bit of formatting. So for that you go to the space, press enter, go to the space, press enter, go to the space, press enter, and then we'll replace our inbound endpoints with the IP address we have. So for first one we have 10.16.40.233. The second one we had 10.16.96.56. So we'll do Control O and enter and Control X. So my file is updated. We can verify it. Control X. And after that we have to restart the server. For that we'll use sudo service named restart. And my server has been restarted. So now what we have done, that we have created a file in my DNS server, and what this file is saying that if any request is coming to resolve this particular DNS name, aws.clouddeepdive.org, then send to these two endpoints. So these endpoints are my inbound endpoints. So request will go to my AWS Route 53 host inbound endpoints, and from there it will go to my Route 53 private hosted zone to check if there is any record or not. So another thing what we need to do now, when the query will go from DNS, so from my app server to DNS, so how the app server will get to know that we need to reach to which DNS servers to resolve this query. For that we have to update our app server as well, and to do that what you will do, you will go to the app server and you will use this command, and you will go to the bottom of the file, and you will say DNS1 is equal to, and here you have to provide the IP address of the DNS servers. So if you go to my EC2 console, and you can see we have two DNS servers. So the first one is, note down the IP address of this and you can paste it here, and similarly DNS2 is equal to, you can note down the IP address of my second DNS and you can update here. Control O, Control X, and after that you need to restart this app server. To do that you will say sudo reboot, terminate it. So what it will do, it will terminate the connection. So what we have to do, we have to close this connection and we can go back to my app server and we can connect it back. So it's going to restart it, reboot the server, and after that we will be able to do it. But in the meantime what we will do is, like we updated our DNS A, we have to update our DNS B as well. So both the servers, DNS servers should have that zone file which we added to our DNS server A. So I'll connect to this as well, and let's go to this file. Let's see if we can copy it or not, otherwise we'll just, and we do same cd/etc, and then we copy our next command, sudo nano etc name.config. So it will open this file, and then let's copy this zone file and go to the bottom of that and paste it here. So need to put Z here, then we can just do the formatting. And then Control O, Control X, and then we need to restart this server. So we'll use our next command to restart it. Okay, so my server has restarted. Now let's go back to our app server and we'll connect to it. So I'm connected to my app server, and what we will do in the app server, since we have already updated all my DNS records for my both the DNS servers, now what we are gonna do, we'll try to ping the IP address. Let's first try the IP address of my EC2 instance to make sure that we are able to ping it. Yes, we are. Now let's ping the DNS name web.aws.cloud deepdive.org, and you can see that it was able to resolve the IP address and it was able to connect to the EC2 instance. So architecturally, what's happening that app server is, because we updated the app server with a file saying that for any DNS related query, go to the DNS server. It's sending request to the DNS server. From the DNS server, we updated the zone file that anything for the aws.cloudtype.org, send it to the inbound outpoints. So it's sending all the requests, DNS requests, to those inbound out endpoints, and inbound endpoints, because that can access the Route 53 private hosted zone, is going and checking there and finding the IP address and sending it back to the app server. So that's how architecturally inbound endpoints are working. Okay guys, so next let's talk about outbound endpoints. So far you have seen that inbound endpoints, how they are working. Next we will create the outbound endpoint. So after getting the outbound endpoints, we will create a rules in Route 53 resolver outbound endpoint saying that any query or any DNS related query which is related to my corporate network, send it to the outbound endpoints, and once it will reach there, it will forward those queries to the my corporate network and will get it resolved from their DNS servers. So let's log into the console and we'll see how you can create the outbound endpoints and how it will work in action. Okay guys, I have logged in into my AWS console and I am under Route 53 section. Under resolver, there is outbound endpoints. We'll click on create outbound endpoints. We'll give it a name. We'll say AWS on-prem outbound endpoint, and we'll select a VPC. So we'll select the VPC where my AWS environment is deployed. We'll choose the security group. We'll deploy it in two different availability zones. So we'll choose both the cases and we'll let system assign automatic IP address. Similarly, let's do it for availability zone 2B as well. And we'll just say submit. So it will create my outbound endpoint and it will again create two ANIs like it created for my inbound endpoints. So it will take a few minutes. After creating this outbound endpoint, we have to create the rules. So under rule, what we have to do, we'll create on create rule. We'll give it a name, AWS on-prem rule, and will rule type will be my forward, and in that we'll give the name of the domain to which we have to connect. So while creating those DNS servers, you might have noticed that we give a domain name of corp.clouddeepdive.org. So we'll use that domain name. We'll put it here, and then you can choose the VPC if you want. As optional. If you want to link or this particular rule with multiple VPC, you can do that as well. So we are linking it with the particular VPC which we are using for our AWS environment. Then we'll use our outbound endpoint, and then you have to specify that which DNS server it should send the query. So basically what we are doing, we created two outbound endpoints. So when the request will go to these endpoints, this rule will be evaluated. And this rule, what this rule will tell the endpoints that where to send these queries when there is any DNS request for corp.clouddeepdive.org is something similar to the zone file which we created, where we mentioned that hey, if anything coming from aws.clouddeepdive.org, send it to these endpoints. So here, these outbound endpoints is sending, hey, anything coming from core.clouddeepdive.org, send to these IP address, and these IP address will be the IP address of my DNS server. So we'll pick up my first DNS server endpoint and we'll add it here. Similarly, we'll pick up the second DNS server, we'll add it here. So that's my first DNS server. and my second will, this is my second DNS server, and we'll click on submit. So this will create a rule which will help us to resolve my DNS query related to on-prem from my EC2 instance in my AWS environment. So next, let's go to EC2 instance and connect to it. So first, let's try, can we reach to this on-prem uh, app server? So we'll do ping. Yes, we can. Next, we will try if we can ping the DNS name of my on-prem server. So for that, we'll say ping and we'll give the DNS name of my on-prem server. And you can say that we are able to resolve the IP address of my DNS of my on-prem server as well. So that's all about inbound and outbound endpoints, guys. Hope you understand how you can use it, how you can use in a hybrid environment to resolve the DNS query of on-prem servers from your EC2 instance sitting in your AWS environment and vice versa. Please do let me if you have any question, or if you run into any issue. I'll be happy to help you out and answer any question you have. Please do like and subscribe to our channel. I will be posting more videos related to AWS service in coming weeks. Thank you so much, guys.